So today we are proving conservation of mechanical energy. We are trying to prove that no absolute time implies the law of conservation of energy. If a force doesn't depend explicitly on the time, then that force conserves energy. So, energy, we are trying to prove that this statement, E2 minus E1 over a period of time, is zero. And in order to do so, you need to calculate the energy. The total energy of something is the sum of the kinetic energy and its energy to potential energy. So, energy equals the velocity or the speed of an object, which is the kinetic energy, plus its position of the object, which is actually the potential energy. And in order to do so, we will be using the equation E2 minus E1 is equal to the sum of the kinetic energy 2 minus KE1 plus the potential energy 2 minus PE1. The energy needs to be divided by time first in order to divide the rest of the kinetic and the potential energy by time. And in order to find the kinetic energy and the potential energy, you need to know the formulas. So first we will figure out the formula for kinetic energy. We know that kinetic energy equals 1/2 m times v squared. So as you plug that in for kinetic energy, you would then be left off with 1/2 m times v2 squared minus v1 squared over t. Now, following algebra, you will then get that K2 minus K1 equals 1/2 m times V2 plus V1 times V2 minus V1 over T. Now, we want to get the 1/2 in front of the equation. It will be V2 plus V1 over 2. Then you are left with the m, and this equation here comes out to delta V over t, which is actually the formula for acceleration. So we can write the a down there. And m times a, as you can see right here, can be simplified to just f. So then you will come out to the change, the average velocity times the force. So your kinetic energy is actually equal to the change of velocity times f. So this is your KE. Now we need to figure out the potential energy part of the equation. So PE to the second minus PE1 divided by time will equal negative x times x2 minus x1 again divided by time, because don't forget, we are trying to figure out why energy doesn't change over a period of time, proving conservation of mechanical energy is true. So the x is actually delta h, or which is the change of height of the object. The F is the mass and the gravitational force of the object. The reason that we have a negative F is because it comes from the fact that if you let the force, say U, push along the potential energy, then the energy will decrease and become negative. But if you are fighting in the opposite direction of the potential energy, then it will increase and become positive. But we are looking at the negative for this problem. So, once you have the negative x and times x2 minus x1 divided by time, you can see that you will see that delta x over t is actually the formula for, once again, velocity. So the equation would then be simplified to negative v times f. Then once you add both the v's and f's from the kinetic and the potential energies, you can then plug it in back to the original equation. The original equation that we are using still is E2 minus E1, again over a period of time, equals KE2 minus KE1 over a period of time plus PE2 minus PE1 over a period of time. Now, by inputting all the v's and the f's that you got, v times f plus a negative v times f will then come out to 0. So as you could say, that no absolute time in physics implies the law of conservation of energy. So now we know that energy does not change over a period amount of time, proving conservation of mechanical energy to be true. Thank you.